All right. Ignore this. Whoopsie. Okay. So this is a review for the quiz or graded worksheet, whatever. And the figure A B C D E H I J F G. I can read. Identify all pairs of congruent parts, then complete the congruent statement. A B C D is congruent to what? So, okay, this is just actually goofy. Now that I look at it, I don't know what happened, but this doesn't make sense because that is not the order they match up. And there's really no reason for this latter part, but we'll just do it now. So it actually should be A, B, C, D, E is congruent to G, F, J, I, H. So G, F, J, I, H. So a little trick I taught you, if you write A, B, C, D, E, and you just write G, F, J, I, H over each other, you can see what matches up. And look, just look over here real quickly. If you look at G, it's this obtuse angle, kind of at the top next to the right angle, F, right? Well, that matches up with A. These are actually reflections of each other, and translated, but you get the idea. So G and A. Well, then G goes to F. Well, then that means A has to go to B. And then down to C, down to J. And it matches up over here. So we'll start listing them. So angle G is congruent to angle A. Angle F is congruent to angle, whoops, I missed my congruent symbol, sorry. And I put two angle symbols, I don't know what's happening here. Just that kind of morning. Angle F is congruent to angle B, and you're just listing them. So J and C. So angle J congruent to angle C. Angle I is congruent to angle D. And angle H is congruent to angle E. Now that's the angles. Now we have to do all the segments. So it goes pretty easy until the end, but if you just look, AB, well, that's just GF. So AB, line segment, is congruent to, GF, line segment. And then, BC, that's FJ. So BC, congruent to FJ, keep the order the same. And then CD would be JI. And then DE would be IH. And then for the last one, we just got to wrap around, and you can either do E to A or A to E and G to H. Okay? So real simple if you just follow that little pattern. Everything matches up. Okay, classify QRS by its side. Then determine if it's a right triangle. So I have no idea what this looks like, but basically we're just trying to find out two things. The length of all the points, okay, and the slope of all the points, right? So to find the length, we need to do the distance formula. So I'm going to do QR first. And remember, it's very simple. I put this ahead of time so I don't have any problems with double negatives. It's x minus x and y minus y. So for QR, right, 2 minus 1 and 2 minus negative 2. You got to be very careful with that going in the same order. So I'm going from Q to R. So 2 minus 1 and 2 minus negative 2. So that gives me 2 minus 1 is 1 squared. And this becomes plus, so that's 4 squared. So to save space, that's, well, no, I'll do it. That's 1 plus 16. So that's the square root of 17. All right? Now I'm going to do RS. I'm going to run out of room here. RS. So I'm going to be doing 1 minus negative 4. And again, here's why I do that ahead of time. The most common mistake is to do this, and that's wrong. Okay? So that's why I urge you to do this ahead of time. And put those minus signs in there so you remember. So when I put in 1 minus negative 4, I'm going to get that double negative and turn it into a plus. And then negative 2 minus negative 4, that's going to become a plus also. So what I end up with is 1 plus 4 is 5 squared, and 4 minus 2, okay, negative 2 plus 4 is 2 squared. So that ends up being 25 plus 4, so that's the square root of 29. So right now we know it's not going to be equilateral, and we know it's not going to be, well, we don't know. It could be isosceles if one of these other ones matches. Okay? And I'm going to do QS or SQ, doesn't matter. Just be careful with the order. Okay? So again, I'm going to put this first. All right? Now I'm going to do QS. That's going to be 2 minus negative 4. And, well, 2 minus negative 4 again, because they're both the same points. So remember, this is going to become plus. So 4 plus 2 is 6. And this is obviously going to be the same thing. So that ends up being, well, I have less space here, so I'm going to have to skip the step. That'd be 36 plus 36, which is 72. So right now you can see that this is a scalene triangle because none of the sides match. And I'm actually going to need to go to another piece of paper just because there's no room for me. You might be able to squeeze it in. So again, I'll just remind us that Q is 2, 2. R is 1, negative 2. And S is negative 4, negative 4. Okay? So now we're going to do slope. And remember, slope is y minus y over x minus x. Okay? So I'm going to do QR first. Put the minus in first to remind ourselves. Okay? So QR, y is on top, so it's going to be 2 minus negative 2. Okay? QR, 2 minus negative 2, and then 2 minus 1 on the bottom. X's go on the bottom. So remember, this is x, this is y is on the top, x on the bottom. So that gives me 2 plus 2 is 4. 2 minus 1 is 1. So that's the slope of 4. Now I'm going to do RS. We'll put the minus in first. So with RS, I'm doing y is on top, negative 2 minus negative 4. And x is on the bottom, 1 minus negative 4. These are both going to become positive. 4 minus 2 on the top is 2. 4 plus 1 is 5. That's 2 over 5. So I did QRRS, now I need to do QS. Again, I'm going to put my minus sign here first. So they're going to be the same on the top and bottom. It's going to be 2 minus negative 4, 2 minus negative 4. Both are going to become positive. And that's going to give me 6 over 6, which is 1. So since we said that all three sides were not equal, we already said it's scalene,
is a scalene triangle. And if you look at the three slopes, for one thing, they're all positive. So we definitely can't have a right angle because we need one positive and one negative opposite reciprocal. So we would need like 4 and negative 1/4, or 2/5 and negative 5/2, or 1 and negative 1. So there's definitely no right angle.
All right, back to the previous page. Number 3, find the values of x, y, and z. Okay, well, first off, you want to look at markings. So x is the same measurement as right here. Okay, we don't know that yet. Y is a side. Notice how it's outside. Okay, so most likely it's going to be here, but let's verify. And z is an exterior angle. So we need to find this one first, which matches one arc, right? So that means this right here is 34 right here because they're the same. All right. So z would be an easy one to find right now, because if we know this angle here is 34, then the exterior angle is its linear pair. So 180 minus 34. So z is 46 degrees. All right. Now, if we know that two of the angles are 81 and 34, to find this third angle here, we need to add these and then subtract from 180. $65. So this angle here is 65. It has 2 arc marks. What else has 2 arc marks? X. So that's 65 degrees. All right. Now, if we look at this, there's also a number 6 here on the outside. I didn't catch that before. So y is one of those two. Now look carefully. 13 is the piece that connects the 2 arc marks and the 1 arc mark. Well, where's that? That's right here. So 13 is not the same thing. And then 6 goes from the 2 arc marks to the 81 here. So that lines up with y. So that is 6. So you got to make sure, you line them up and find, road maps and road signs to help you guide your way. All right, show the two triangles are congruent. Explain your reasoning. Well, we have not yet learned a rule that would make this very easy. So, what do we know? Well, we know that this lines up with this. Okay. This is congruent to this. And this is congruent to this. So all the sides match up. So that's good. We have this angle here is 90. This angle here is 90. These two angles are equal to each other because they're vertical. And that means if they both have the same two angles here, that means this angle must match up with this angle. Okay, so let's get a congruence statement. Pick a letter, doesn't matter where you start. Let's say I'm going to start with L. Okay, so triangle L, and I'm going to go MP. Now let's see what matches up on the other one. Notice that L has 2 marks. So that means it's going to be congruent to O because it has 2 marks. I went to M, which is the vertical angle. So I'm going to go to M here. And then I end up at P, which was the right angle, so I'm going to end up at N here. And the reason we know this is all parts are congruent on both triangles. So we have a rule that if all the parts match up, then the triangles are congruent. Now, just a little foreshadowing. In the next section, we're going to learn a rule called side, 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 which would have made that extremely easy because we could have just said all the sides match up, we're done. All right, find the value of x. All right, so a lot going on here. This is an exterior angle. Remember that exterior angles are equal to these two added together. All right? So, if we take 2x plus 6 and add 36, that's going to be equal to the exterior angle of 4x minus 18. This is the exterior. All right? So, I combine like terms. 2x plus 42 equals 4x minus 18. I want to keep my x's positive, so I'm going to subtract 2x from both sides, which means I'm going to add 18 to both sides here. Oh, didn't mean to do that. So that's going to be 4x minus 2x is 2x. 42 plus 18 is 60. And then 2x equals 60 divided by 2. X is 30. Now notice, follow the directions. It only told me to find the value of x. It did not say plug it back in and find any angles. But if I did, plug it in here, 4 times 30 minus 18 would give me the exterior angle. 2 times 30 plus 6 would give me that angle. And I could find this angle right here two ways. Either 180 minus the exterior angle, or these two added together subtracted from 180. But again, the instructions just said find x. All right, number 6. There's two ways to do this. There's the longer way, which is no big deal, because all the angles add up to 180 in a triangle. So 2x plus 3x plus 5 plus 90 equals 180. The shortcut basically says if this is 90 right here, that means there's 90 degrees left for these two. And that's going to look really familiar here in a second. Okay, so on this side, I'm going to join like terms and get 5x plus 95 equals 180. Over here, I'm going to get 5x plus 5 equals 90. When I subtract 95, I'm going to get 85. Over here, when I subtract 5, guess what? I'm going to get 85. And now we're at the exact same point. The only thing is the one on the left required a little bit more number crunching than the one on the right, but it doesn't really matter. Okay, it's only a slight shortcut. All right, and then when I divide by 5, x equals 17 on both. Okay, and again, it did not ask us to find any values, but if I wanted to, 2 times 17 is 34. Okay, 3 times 17 plus 5 would give me that angle. All right, the measure of one acute angle of a triangle is 12 more than 3 times the measure of the other acute angle. Find the measure of each angle of the right triangle. That's key. If we didn't have that, we couldn't solve it. Okay, so we have a right triangle. And we have 2 acute angles. One of them is 12 more than 3 times the other one. Well, that means if this one is x, this one here is 12 more than 3 times the other one. Okay, and again, you have two choices here since it's right. You could say 3x plus 12 plus x plus 90 equals 180. I'm just going to do the shortcut because I know that these two angles add up to 90 because that's all that's left in a right triangle. So that's going to give me 4x plus 12 equals 90. I'm going to subtract 12. It's going to give me 78. And I'm going to divide by 4. 4 goes into 7 one time. And this is going to end up as a decimal, 19.5. All right. Now it says find the measure of each acute right triangle, each angle. So we know this one is 19.5 degrees. And the other one is 3 times 19.5 plus 12. So 19.5 times 3 is 58.5. And then if you add 12, you get 70.5. So this angle here is 70.5 degrees. Decide whether or not we have enough information for SAS. So again, if you use this little trick, this makes it a lot easier. So this is S, this is S. They match up. This angle matches up with this angle, and this side matches up with this side. Do I have SAS here? Yes, I do. Do I have SAS here? Yes, I do. The answer is yes. Okay. Here, I have a side that matches up with this one. Here, I have a side that matches up with this one. I have no angles that are marked, but I do know that this angle matches up with this angle, which means I have A right here and A right here. Now, for SAS, I would need this angle and this angle, which I do not have. What do I have? ASS. And there are no donkeys in geometry, so this is a no. Okay, on this number 10, I have a side here that matches. I also have a side that's not marked that matches. Now, this one's a tricky one because I have angles marked here and here and here and here that are congruent to each other. But those are not the included angles. Those are not the angles in between. I would need these angles here, which I don't have marked. But I do have two angles marked in both triangles. And remember, we have a rule that if two of the angles are the same, the third must be the same. So we can mark, just like over here, we can mark vertical angles. We can mark this one. I'm going to mark it with 3 because we have a 1 and a 2. And now I have side angle side. So yes. All right, number 11, a proof. Very simple one. Okay, so we know that angle ABD is congruent. Oh, I'm sorry, my bad. I can read. And angle CBD are right angles. Okay, right here and right here. And we're told that BD, I don't know why I wrote a 9, bisects AC. These are both given. So BD bisects AC. So that means we know these two pieces are equal. But we still need to say that. So we just say AB is congruent to CB. And that's just the definition of a bisector. Okay? So you know those two parts are congruent. We also know always these lines are congruent to themselves because they're the same line. That's a reflexive property. And look what we have. We have a side, we have an angle, and a side. Side, angle, side. Now we should have one more in there. It's kind of a nitpicky one, but we should say that angle ABD is congruent to angle CBD. All right angles are congruent because they're all 90. And then at this point, we can say the triangle ABD is congruent to triangle CBD by SAS. All right, find any of the missing variables. All right. So, if you notice, we have these markings here that the angle, the line segments are the same. That means in an isosceles triangle, these angles are the same. Right? Well, let's think about it. We have 130 degrees right here. So that means if we start off with 180 and we use up 130, what do we have left? We have 50. But that 50 has to be split up evenly here and here because they're equal to each other. So I need to do 50 divided by 2, which is 25. So each of these angles are 25 degrees. All right? Now, over here, we see that the angles, the base angles here are the same. They're equal to each other, which means these line segments are the same. So I can say 3 times x plus 2 in parentheses, careful, equals 24. Now, there's two ways to go about this. I can distribute the 3, right? And I'll end up dividing by 3 later. Or, since this number is divisible by 3, I can just get rid of it now. It's up to you. I personally like to get rid of it when I can and save time and keep the numbers smaller. So that is going to cancel and leave me x plus 2 equals 8. And then I'm done. Just subtract 2. X is 6. All right? And it just wanted me to find the variables. X is 6. Now, real quickly, if I had done it the other way, I would have had 3x plus 6 equals 24. No big deal, not hard, big numbers, but just more work because I had to subtract 6. That gives me 3x equals 18. Divide by 3, and I get 6. Not a big deal, just a little bit quicker. You choose what's best for you. All right, find the value of any missing variables. Okay, a lot going on here. So, right off the bat, if you look at the overall triangle, the big triangle first, forget about that line in the middle, we see this and this are marked equal. Okay? Along with this. So we have an equilateral triangle, which means all the sides are the same. So if this base down here is 46, that means this is 46 and this is 46. All right? But if you look at the triangle we start off with, we have part of it is 16 and the rest makes up the 46. So all we have to do is y equals 46 minus 16, which means y is 30. Okay? Now, this also means if these are all equal, these are all 60 degrees. Okay, so if I have 60 here and I have 80 here, I can find out this angle right here by adding 80 plus 60 and get 140, and then 180 minus 140 is 40. So this angle here is 40. But remember, the whole thing is 60. So if part of it's 40, x is equal to 60 minus 40, so x is 20. On to number 15. Again, we have a 60, 60, 60 triangle here, right? Which means all the sides are equal also. Now, if this angle here is 60, all right, that means this angle here is the linear pair. That's 180 minus 60, which is 120. Now, if you notice that this is marked here and here as equal, okay, that means that triangle there, that this angle is equal to this angle. Okay? So this takes us back to the previous problem. If the one angle up here is 120, if I do 180 minus 120, that gives me 60. And then these angles have to be equal because it's an isosceles triangle. Therefore, this is divided by 2. So x is 30. And then for the side, again, if this is marked 20 and this is marked 20 and this is an equilateral triangle, every one of these is 20. So that means 5y equals 20, so y is 4. It's just kind of like dominoes. You just got to find the one piece and then everything else comes knocking down. All right, and our last problem is another proof. All right, and we're given that angle EBC is congruent to angle ECB. That's these two right here, right? And we're also given that AE is congruent to DE. So AE, which is this little piece right here, is congruent to DE, which is this piece right here. All right, so we got a lot going on here. Now, since these angles are equal here, that means these pieces are also equal here. So I'm going to mark those. And then we also have some vertical angles going on here. So look what we have. Side, angle, side, side, angle, side. Now we just need to justify it all. So first off, we said that EC and EB were equal. And that is because if the base angles are congruent, then the diagonals, the opposite sides are congruent. So that's the base angles converse. Okay? Again, you get to use your notes, so you don't have to have these memorized. So base angles converse theorem. And then we can say that AEB is congruent to DEC. Vertical angles are congruent. And we're done. Triangle ABE is congruent to triangle DCE by SAS. And that's it.